All right, physics class, we're going to dig deeper into projectiles here. Lesson 3.4 is looking more at the displacement, or you could say the position of a projectile that's launched in the air. How do we figure out how high it is, or how far it goes horizontally? So here's a example. We'll just do probably one example here. A projectile is launched at 40 degrees, velocity 30 meters per second. Find the position now, okay? Or you could say displacement at 1 second, 2 seconds, 3 seconds. Okay, to start out, it's the same as we've done. You need to find the components. All right, so let's draw this out. 30 meters per second, that goes here. The 40 degrees is here. All right, and then we need to find the VXO and the VYO, the initial components here. And again, just for the sake of time, and hopefully you're getting used to this idea that to find this one is actually a cosine. It'll be 30 times the cosine of 40 degrees. Okay, that's your VXO, the initial x velocity, 22.98. I'll say 23.0. And then this one's going to be a 30 times the sine, right, of 40. I should have left a little more room over here, but that's my VYO, which is actually over here. Let's see what that comes out to. 30 times sine 40 degrees, 19.3. These are meters per second. Okay, that's the same as we've done. So now the new thing is position, okay? So there's these equations for position. Let's write these up here. So we're going to say dx, okay? The displacement in the x direction. Just take your VXO times t. All right? In other words, take this speed here, this velocity, and just times it by however many seconds, because remember, this is just going at a constant velocity to the side. So if it went for 3 seconds, I would just say, well, take this times 3. That would tell me how far it went sideways if I'd follow it sideways. dy is where it's accelerating, right? So that one's a little bit trickier. Okay, it actually looks familiar to, hopefully, to the equation from chapter 1, except for them adding these y's in here. So to find the displacement in the y direction, you take your initial displacement, which most of the time will be 0, unless you're going off a cliff. Then you take your VYO times t, and then plus 1/2 AT squared. So it's really pretty much that VOT plus 1/2 AT squared that we looked at in chapter 1. All right, so let's break this down. Let's see where we're at 1 second. We'll do 1 second and 2 seconds. Maybe I won't do 3 just for the sake of time. Okay, so we're wondering what this position is. dx, pretty easy. Once you got your numbers, it's going to be the VXO times the t, so 23.0 meters per second times 1 second, obviously, is 23.0 meters. Okay, that's how far it went horizontally. And then your dy, how far is this up in the air? DYO is 0. Your VYO is the 19.3 times 1 second plus 1/2. Our A is a negative 9.8 times 1 second squared. Okay, so it's just a matter of plugging all that stuff in there. Really, it's just going to come out to 19.3, and then here's going to be what? Minus 4.9, I believe. Okay, so I'm getting 14.1. I'm sorry, 14.4. Okay, that's how high it is off the ground at 1 second. Okay, 2 seconds, it'd be nice to draw it over here, but I'm just going to do it down here because it takes a lot of room on these problems. So at 2 seconds, your dx, again, just go back to your equation. It's just your VXO times your T. So it's just 23 meters per second times 2 seconds. You're talking 46 meters. Okay, that's how far it'll be horizontally. If you were running directly underneath it, you could say. dy, go back to your equation. Our dyo is 0. Our vyo is a 19.3 times 2 seconds now, plus 1/2, negative 9.8, times now 2 seconds squared, okay? So I'm just plugging in 2 in for the time here is all I'm doing. Okay, that one, let's work that out. 19.3 times 2. And this will end up being a minus 0.5 times 0.8 times 4, right? 19.6. Okay, so 38.6 minus 19.6, 19, okay? That's your Vy, I'm sorry, your dy. That's how high it is off the ground, okay? This is gonna keep going. Actually, it started to come down already. Because you look at it here, yeah, maybe not quite, okay? It's at 14 here, it's up to 19. Probably if I went to 3 seconds, this would start coming down, okay? Because the ball's gonna start coming back down to the ground, okay? This obviously is just gonna go up constantly, 23, 46. The next one would be like 60, 69, okay? So hopefully that makes sense. That's kind of the basics you need to get started here. We'll keep digging into this the next few lessons though.